Hello guys, welcome back. Today we are looking at the polar coordinates, and we have to look at the relationship between polar coordinate and the rectangular coordinate. Polar coordinate, it is represented by r, comma, theta, and rectangular coordinate, it is represented by x, comma, y. And we have the diagram which explains only polar coordinate and the rectangular coordinate. Polar coordinate, it is represented by theta and r. For rectangular, it is represented by x and y. This is the x or y plane. Then we all know that in vectors, x component, it is represented by r cos theta. For number 2, y component, it is represented by r sin theta. When you are asked to find the value of r, you use a Pythagorean theorem. This is for number 3, which is r squared, it will be equals to x squared plus y squared. This is a way when you ask to find the value of r. Then here, if you can see, x equals r cos theta and y equals r sin theta. So for tan theta, it will be equals to y over x, because tan theta in identical, we all know that it is sin theta over cos theta. For y, we all know that we have sin theta, and for x we have cos theta. So that means for tan it will be y over x. So now let's try to look into some of the examples. For example 1, we are asked to find the rectangular points if the polar coordinate it is 2, pi over 6. Here we have r and theta. So now let's try. So now for x component, we all know that it is x equals r cos theta. X equals, for r we are given that it is 2. Then for r it is given that it is 2. And for cos theta it is pi over 6. X equals 2 cos pi over 6, it is in radians, so let's take it in 2 degree, in which we are going to say pi. Then pi and pi goes, we remain with 6 into 6, 6 into 180, which is 30 degree. So that means here we have a 30 degree. And if you can see, 2 cos 30. So let's try to draw ratio angles. This is cos 30. Cos, we all know that cos, it is cos theta, it is equals to adjacent over hypotenuse. So adjacent, it will be root 3. X equals 2 multiplied by root 3 over hypotenuse, we have 2. So here 2 and 2 goes, then we remain with x equals root 3. So let's try to see for y component. So for y component, it will be substitute also here. R we have 2 sin theta. So let's take 30 here. We have 30 degree. Y equals 2. From our special angles, sine, we all know that it is opposite. opposite over hypotenuse. So opposite over hypotenuse, it will be multiplied by half. So in which it will be y equals 2 and 2 goes, we remain with the 1. So the representation for rectangular coordinate, it will be, because we have found the x, it is 3 and y 1. So for x we have root 3, comma, for y we have 1. This is our answer for this question here. So now let's try to look into another example. Give all possible polar representation of the point with the rectangular coordinate. Here we are given the rectangular coordinate. So we have to find the polar coordinates. So now, even here we have to draw. Here for y, this is our coordinate which we have here. For x we have 1, for y we have 1. So that shows that this is a special angle, which we all know that here we have 90, here 45, here 45 degree, here 1 and here 1, here we have root 2. So now here what we are going to do, because we are asked to find r, so for finding the r we have to introduce a Pythagorean theorem, in which to be r squared equals x squared plus y squared. R squared equals, for x we have 1 squared plus 1 squared. So r squared equals 2. R squared equals 2. When you provide the square root both sides, r it will be root 2. So this is it. So we have found one coordinate which is root 2. So now let's find the angle. We all know it is in this way, which is r theta. So we have found the r. So let's find the theta now. Let's find theta. So for finding the theta, we have to use x component or y component, in which it will be x equals r cos theta. For x we have 1, which is equals to r. We have found that it is root 2, then cos theta. Then we are going to divide by root 2, in which we are going to remain with the cos theta equals 1 over root 2. Then let's look for angle, in which we are going to do theta equals cos inverse of 1 over root 2. And 1 over root 2, it is 45. The inverse of 1 over root 2, it is 45. So we have to take 45 into radian, in which it will be pi over 4. So let's find other values. If we draw a quadrant here, 45 it is here, 45 it is here. The way polar coordinate does, it moves opposite direction. So here we have 45 also, and r, it will change, it will be negative. So we have found that here we have root 2 comma pi over 4. We have to add plus 2 pi, n represents all integers. So let's find the other coordinate. These are other possible values. Let's find the another values here. If you can see from this quadrant, we have 45. So we are moving from here up to here. So it is it is going to be 180 degree plus 45, which is equals to 225. And 225, if you want to take it into 225 degree, if you want to take it into radian, it will be, we all know that 180 degree represent pi. What about 225? It will represent x. So 180 x, if you cross multiply, 180 x equals 225 degree. I'm going to divide throughout by 180 degree, 180 degree. Then here 180 and 180 goes, x equals, here we have pi, because 225 by pi, it is 225 pi. So here we are going to look for two numbers which can go into 225 and 180, which is 45. 45 into 225, it will be 5 pi over, into 180, it will be 4. So this is the angle in radian. So here we are going to have minus root 2 comma 5 pi over 4 plus 2 pi n. N represents the values for all integers. So this is our answer for this question here. We have found all possible values which represent the rectangular coordinates. Thank you for watching, and don't forget to subscribe and turn on the notification bell so the next time you see any updates.